Assalamualaikum warahmatullahi wabarakatuh. So welcome back to our online class. So this we are still in the chapter 4 of the quality engineering, which is under chapter quality tool. So this is last subtopic of the quality tool, which is statistical process control. So statistical process control is normally will apply in the manufacturing, especially if you work as a quality engineer, you work as a process engineer, production engineer. So whatever department you will attach, you will deal with the SPC. So in manufacturing process, quality control have to monitor the process of variation. Alright. So what is a variation? Variation is the variety of the data. Okay, if we collect some data, for example, we need 10 mm. We cannot get 10 mm exactly. What we get 10.1, 10.2, 9.5, 9.7, 9.8. Right? So this is we call it variation. Alright. So by using a quality tool, the root cause of the variation can be determined, while correction and preventive action are taken immediately. And control chart, we use SPC, or others word we call it control chart. Control chart is used to monitor the process. So what we need to monitor is a common cause and special cause. So what is a common cause? What is a special cause? I will explain later. Alright. So normal chart, control chart, SPC or control chart. If previous chapter we learned about the normal distribution or normal curve. Normal curve, we when we turn the normal curve into the 90 degree. So what we can see is actually we can convert it into the control chart. Okay, so the out of control consider special cause. Inside the control consider is a common cause. So this is common cause, this is the special cause. Alright, so what is the special of the control chart? Alright, so in control chart, we will calculate the central line CL. We will calculate the upper control limit and lower control limit. The other term people use in manufacturing is SL, USL, LSL. So what is the difference between UCL and USL? Okay, UCL, upper control limit or lower control limit, is we will control in-house, and USL, upper spec limit and lower spec limit, this is determined by the customer. So that means UCL must be lower than SL, CL must be lower than SL. Okay, control limit must be lower than spec limit to make sure our process variation is meeting the customer specification. Okay, so how to control? Okay, the concept of variation. So what I mentioned earlier, this is common cause. This is special cause. This is common cause. So we cannot get exactly the value here, the value in the center line. Okay, this is impossible for us to get the data like this. Like your class, although all of you cannot get 70, all same. Some of the people may get, some of students will get 71. Some of the students will get 82. So that means the data is not constant. Alright. So how we will control this one? So in the control chart in the previous chapter, I also mentioned two types of data we have in the manufacturing, which is number one, the data of the variable data. This second one is attribute data. So just want to recall what I mentioned before. Variable is a variable data referred into the data we can measure, or data will have the unit mm, second, cm, inches, hertz, decibel. This is all considered variable data. Attribute data is we count. So as COVID now, the data of COVID is the counting the number of the data. So that is considered attribute data. Alright, we have two categories of the control chart. Number one is a variable control chart, and number two is attribute control chart. Alright, so if for the variable control chart, we'll have four control we have a 3 control chart, and attribute control chart we have 4 control chart. Different situation apply different control chart. Okay, all right. So how we want to differentiate between the control chart? All right. If let's say we have the data, we want to determine variable or attribute. We need to determine the data is a data variable or data attribute. All right. So if let's say data variable, we will have a 3 type of the control chart, which is IMR, individual moving range, S bar R, bar and range, or S bar S, mean and standard deviation. Okay, if let's say our data is attribute, we have a 4 type of control chart, which is MP chart, P chart, C chart, and U chart. So how to differentiate how to differentiate the for the control chart for the variable, how to differentiate control chart for the attribute. Alright, when we collect the data, every day we collect the data. In manufacturing, how they collect the data, they will collect based on the sampling. So if let's say single sampling, that means every day or every time only collect one data. Every day only collect one data. So that type of category we must use IMR chart, individual moving range. Okay, if let's say our sampling size is between 2 to 9, we must use S bar R. Okay, IMR is a individual moving range, S bar R is a mean and range. If let's say our data more than 10, more or equal than 10, so we must use S bar S, mean and standard deviation. Okay, now clear? Alright, so what about is a attribute data? If let's say the attribute data, so it's depend on the situation, constant table or constant sample size. A constant sample size for the MP chart and P chart. If let's say constant sample size, we will use MP chart. What is mean sample size? Sample size is we collect 10 sample. Every day collect 10 sample. That means we need to use NP. What is NP? NP is a non-proportion. That means numbers. Okay, if let's say non-sample size, today we collect 10 data, tomorrow 11, and the day of tomorrow after tomorrow is 15, we must use a P chart. What is a P chart? Proportion. Okay, if let's say number of defective, the number of defect is we collect sample size is constant or not constant. If let's say constant, we will use a C chart. If not, we will use a U chart. So what type of control chart this one? I will explain every single chart, don't worry. Okay, so far okay. Alright, so we move to the next one. Okay, this is the summary of the type of control chart: S bar S, IMR, and S bar R for the variable data, and P chart, NP chart, C chart, and U chart for the attribute data. Okay, alright, so this is it. Now for this video, I will explain about the variable control chart. Okay, subgroup or sample size is 1 is IMR, individual moving range. If let's say 2 to 9, S bar R, or subgroup or sample size more or equal than 10 or more, must use S bar S. Okay, most of the people in the manufacturing, they use this type of control chart. Why? Because of their sample size maybe 3, maybe 4, maybe 9, not more than 10. Okay, now we go for, this is how we interpret the graph if we plot the control chart. So for example, the first situation, we will have a natural pattern. What is a natural pattern? Natural pattern is all the data inside the range. or inside the control limit, upper control limit and lower control limit, or the data inside the control limit. Here we call it natural pattern. Or some of the situation we will found data out of control limit. So this is the special cause. Okay, either are more than upper or less than lower. Okay, some of the situation we found in our data is a consecutive point near to the UCL. Okay, or consecutive point near to the LCL. Okay, this is not reject, but this is the role of the engineer to study to make sure the data is near to the center, to bring back the data into the center. Okay, or some situation we found this category which is run above the center line. That means our data is not centered. That's why previously we calculate mean, median, mode, standard deviation, average. Okay, and this is also sometimes we found in our data cycle. Okay, suddenly the level shift suddenly happen. So this is why maybe something happened into our machine. Or level shift, gradual level shift. This is about the talking about the suddenly the data is changed. Why? That's why we need to always ask ourselves why. Okay, the trend, the data is keep increasing, like COVID, right? Okay, erratic behavior near to the upper and near to lower. Okay, and okay, so over control is so we need to investigate why the data like this. Okay, and also the mix pattern. This is above the central line, this is lower the central line. So that's how we interpret the control chart. Okay, all right, so for the first data, the first control chart is a individual moving range, but I have not enough time to cover in individual moving range because every video I only can upload for 15 minutes, but I will continue with the next video, which is we cover individual moving range, S bar R and S bar S. Alright, so thank you very much for your time for watching this video. See you in the next video. Alright, thank you very much. See you again. Assalamualaikum warahmatullahi wabarakatuh.